complex fractions are just a way of saying there's a fraction within a fraction. So there's a fraction in the numerator and the denominator of a fraction that already exists. So there's two ways that you guys can solve, or simplify rather, a complex fraction. You guys can use method 1. And that says, if necessary, simplify the numerator and denominator by writing each as a single fraction. So if you guys can write each of them as a single fraction, then you can divide the numerator by the denominator, essentially multiplying by the reciprocal. The second method is the way that we're going to usually do it. So that first method is if you have a single fraction over a single fraction. But the second method, it says multiply the numerator and the denominator by the least common denominator of every fraction in the problem, or in the numerator and the denominator. Then simplify. So the first method, there has to be a fraction on the top and bottom. Second method, you can always use just find the lowest common denominator of every fraction in your problem. So let's actually go ahead and try to simplify them. So the first way we're going to do is just by simplifying when there's a fraction in the top and bottom. So the first method is when you have a fraction over a fraction, and you can just divide by that fraction. And remember, dividing by a fraction is like multiplying by the reciprocal. So this will become 2/3 divided by 5/6, which then becomes actually multiplied by 6/5. So this just equals 12 over 15, which reduces to 4/5. So when there's just a fraction over a fraction, you can divide by that fraction and essentially multiply by the reciprocal. So let's look at number 9. It's 3 over 6 divided by x minus 2. So I'm going to make this, you can make anything a fraction by putting it over 1. And then that will become 3 over 1 times the reciprocal, x minus 2 over 6. So this becomes, if you guys multiply, 3x minus 6 over 6. And you guys can reduce all of those by 3. And it will become x minus 2 over 2. So to go from a fraction within a fraction to just a single normal looking fraction, if there's just one on the top and bottom, you're going to divide by that fraction by multiplying essentially by its reciprocal. So go ahead and try the one that we skipped there. And I'm going to continue on here. So number 10, it's 4/5 plus x halves over 3/10 plus x. Now, since we're working in fractions, it seems silly to think that making more fractions would make our life easier, but it does. If everything is fractions, it's easier to work with. You don't want some things that are fractions, some things are not that are not. So I'm going to make this x over 1. So what you guys are doing is looking at all of your denominators. So your denominators are 5, 2, 10, and 1. And we're going to try to find the lowest common denominator here. So if they're all numbers, none of them are a variable, none of them are x's, the lowest common multiple, the lowest number that 10, 5, 2, and 1 go into is 10. So that's going to be, just like what we did before, the new common denominator for the top and bottom. So I'm going to try to write this as organized and neatly as possible. So we're going to have one big fraction where the numerator and the denominator have that common denominator of 10. So if we're looking at this, the first fraction, do it one at a time. 5 times what do we need to get us to 10? 5 times 2. So you want to multiply the top and bottom by 2 over 2. The bottom becomes 10, which is what we already have. 4 times 2 is 8. Bring over your sign. Okay, that one's done. Next one. We have x over 2. We want it over 5 or over 10. So 2 times what? What do we need to multiply 2 by to get us to 10? 5. Or you're essentially dividing. 10 divided by 2 is 5. So you guys always just multiply. That becomes 5x. All right, top's done. Next is your bottom. In this case, your denominator is already 10. So 10 divided by 2 is 1. So if you want to, just for good practice, multiply it by 1 over 1, you can. But it's just going to stay 3. Bring over that plus sign. And your last one. Our denominator is currently 1. We need to get it to 10. So we need to multiply by 10 over 10. So that's going to give us 10x. Now here's what happens. We still have a fraction within a fraction. But if you use that method, and I'm going to write this down and then erase it. If we were to multiply 8 plus 5x over 10 by the reciprocal of the bottom, which would be 10 over, or 10 plus 10x plus 3 over 10. Nope, I was right the first time. 10 over 3 plus 10x. What happens is those denominators always end up flipping and canceling out. That's why we make the common denominator, because they always end up going away. So what happens is this big fraction up there, your denominators are going to cancel, and you are just left with 8 plus 5x over 3 plus 10x. And you can't factor anything out or simplify, so that's just going to be your final answer. So the process is still the same as when we add and subtract expressions. It's just you have more fractions to look at a single time. So let's try another one. So in this problem here, we've got 4 over x plus 4 plus 2. That's your numerator. All over 5 divided by x plus 4 minus 1. So again, just to make my life a little easier, I'm going to put everything that's not a fraction over 1. And so now you guys are still looking at your denominators, so all 4 of them. So in this case, your LCM, or LCD rather, needs to include x plus 4. Remember, we only need one of them, because that's most that one of them has. And if you want to include 1, you can. So as we move along here, that's going to be the new common denominator for the top of our fraction and the bottom. So, same process. We found the common denominator. Now we have to go back through and say, okay, what does each one need to be multiplied by? So in this case, I didn't need to include 1. It's just good practice. Helps you sort of get in a rhythm. The x plus 4 technically needs to be multiplied by 1 over 1. It's not going to change anything, but 4 times 1 will give us 4. Bring over your plus sign. Your second fraction just has the 1, so it needs the x plus 4. And remember, the 2 needs to go to both of them, so 2x plus 8. Okay, on the bottom, the 5 has the x plus 4, so technically 1 over 1. 5 times 1 is 5. Bring the minus. And this one only has the 1, so it is missing the x plus 4 from that common denominator. So 1 times x plus 4 is just x plus 4 in parentheses. So again, those common denominators, guys, are always going to cancel. And you're going to end up getting just the numerators of the top and bottom. So you'll end up with 4 plus 2x plus 8 over 5 minus x minus 4, because that negative is going to distribute. So if you combine everything, you'll get 12 plus 2x over 1 minus x. Can't simplify or reduce that, so that'll be your final answer. The key here, guys, is really just to make sure that you guys are trying as best as possible to just keep everything organized. So keep on moving along here. So for this example, we have 2d divided by, and this is just comes from an application problem, so I'm not sure if r stands for radius or what it might stand for. But it's two values, so d over r1 plus d over r2. r1 and r2 are two different values, we just don't know what they are. So again, to make my life easier, I'm going to put 2d over 1, so everything is a fraction. And still, you're looking at every single denominator that you have in your problem. So in this case, we have 3. So my LCD, my lowest common denominator, needs to include r1, r2, and technically 1, but we don't need to include that. So as we move along here, that's going to be the common denominator for the top and the bottom. So if we're looking at the top fraction, it has just the 1 in its denominator, so it's missing both of them. So it needs r1 and r2. So the bottom will just become r1 times r2, and the top will become, I'm just going to write it the same way, 2d times r1 times r2. There's nothing being added or subtracted there, so it can just sort of all stay together, being multiplied. Okay, on the bottom, your first fraction has r1, so it needs to be multiplied by r2. So that becomes d r2. Bring over your plus sign. The second one has r2, needs to be multiplied by r1. So d times r1. So always, always, those denominators go away, and you're just left with the numerators. So 2d times r1 times r2 over, and I'm actually going to factor out a d here, guys. So instead of making this d times r1 plus d times r2, I'm just going to factor out the d because both of them have that d attached. And we're going to make this d times r1 plus r2. And when I do that, then my d's here will reduce to just simply 1d, or to 2. The d's will reduce because technically this is 1. 2 divided by 1 is 2. So 2, d is gone. r1, r2 over r1 plus r2. So does it seem a little crazy? Yes, because of the r1 and r2, they're not actual values, but process is still the same. Factor out your denominators. Find the common denominator, multiply by what you're missing, simplify if needed. I'm going to do one more with you. Okay, so we've got 6 over x minus 5 plus 1 over x all over or divided by 3 over x minus 2 over x minus 5. So, still the same thing. If you needed to factor the denominators, you would need to do that. But in this case, nothing's factored. You just need to look at every single denominator. What do we need to include in the common denominator to make sure everything is covered? So your common denominator here would need to include x minus 5, just one of them. None of them have more than one. And a single x. So that'll be your common denominator. So let's write one big fraction with x minus 5 and x minus 5 and x. Okay, now we must see what we need to multiply. So the first one, its denominator has x minus 5, so it's missing the x. And remember, it's x over x. We had to multiply by a value equal to 1. So 6 times x is just 6x. Bring over the plus sign. All right, second one has the x. It needs x minus 5. X minus 5. Multiply the 1. That'll just be still x minus 5, because 1 times anything is itself. All right, bottom. This one has the x. It also needs to be multiplied by x minus 5. So distribute your 3 and get 3x minus 15. Bring over your minus sign. And then the 2 has a denominator of x minus 5, so it's missing the x. 2 times x is 2x. Denominators are gone. And you've got 6x plus x is 7x minus 5 over 3x minus 15 minus 2x, so 7x minus 5. Combine your like terms, x minus 15. I know I went through them a little quickly, but you guys can always pause and go back to wherever you need to, or if you need to, but that would be simplified. So again, does it seem like a lot of work? Yes, but just make sure you guys are keeping your work organized and paying attention to what's going on, and you should be fine.